Hey guys, in this video, I'm going to show you how you can create a site-to-site VPN connection between a virtual network gateway, which is a VPN gateway in Azure, and a virtual machine that is installed with routing and remote access role in my on-premises network. This would help us to connect the Azure virtual network to an on-premises network. With this connection, you can do things such as extend your Active Directory from your on-premises to Azure, or you can migrate the VM from your on-premises to Azure. But you can do many more things with this connectivity. I've already built a lab environment for both my on-premises environment as well as Azure environment. The on-premises environment is a lab built on top of my standalone ESXi host, and all the servers are virtual machines. Let's look at the networking setup on my ESXi host. I'm using two standard switches, vSwitch 0 and vSwitch 1. vSwitch 0 has two port groups, Internet and ESXi Desktop Management Network. This port group Internet is used for providing Internet connectivity to my gateway VM router 01, which has two network adapters, and the second network adapter of this VM is connected to this port group. The port group ESXi Desktop Management Network is used for VM kernel network adapter for the management of my standalone ESXi host. The management network IP address is 192.168.1.99. The vSwitch 0 has a single 100 meg network adapter, and it is connected to my home network 192.168.1.0/24. You can also see I'm not using VLANs for these port groups, and all other configurations with this standard switch vSwitch 0 is standard and default. Now let's look at vSwitch 1. vSwitch 1 is used for hosting my internal network to simulate an on-premises networking setup. As mentioned before, all the security settings are set to accept. This standard switch has no network adapter attached, and no other settings needs to be changed. This standard switch vSwitch 1 has a single port group called Management. This port group used for management network, and it simulates an internal on-premises network using this port group. The first network adapter of virtual machine DC01, which is my domain controller, server 01, which is a member server, and router 01, which is a gateway virtual machine, are connected to this port group. The VLAN ID of management port group is 10, which is assigned at this port group level. This table lists the IP subnet, subnet mask, gateway address, and MTU of my internal network. Each port on the management port group works as an access port, and when a VM's network adapter is connected to this port group, it is more like connecting to an access port on the physical switch. While creating the management port group on the standard switch vSwitch 1, the security settings of the port group is set to inherit from the vSwitch, which is from vSwitch 1, where the security settings such as promiscuous mode, MAC address changes, and forged transmits are set to accept. Here are the virtual machines and their roles that I've already built and configured in my on-premises environment. I've already configured an AD domain called tastybiryani.local on the domain controller DC01, and in my environment there is a member server called server01, which is joined to the AD domain but not configured with any roles and features. Both these VMs, DC01 and server01, have a single network adapter connected to the management port group, and their IP configuration is listed in this table. The virtual machine router 01 acts as the gateway appliance for my on-premises environment. I've already installed routing and remote access role on this VM with remote access role and routing role service. This VM has two network adapters, network adapter 2 connected to Internet port group, and it provides the Internet connectivity to my on-premises environment, and network adapter 1 connected to management port group, which acts as the gateway interface for my internal network. Also make sure you disable the firewall inside the guest operating system of these on-premises VMs for testing purpose, or at least allow the ping traffic. For this demo, I have created a VNet called VNet1. The IP address space of the VNet is 10.0.0.0/16. I've also created a subnet called subnet1, and the IP address space of the subnet is 10.0.0.0/24. This subnet1 is used for hosting Azure VMs. When it comes to virtual machines, for this demo, I have provisioned a single VM called VM1, and it is connected to the subnet1. The private IP address assigned to this VM is 10.0.0.4/24. For testing purpose, I have configured this VM with the public IP to use RDP, and I've also disabled the firewall inside the guest operating system of this Azure VM for testing purpose. Or you can allow the ping traffic if you don't want to disable the firewall. You can see I've created a NSG inbound rule to allow ICMP traffic to this Azure VM from on-premises network for testing purpose. Since this is a lab environment built on an ESXi host and the environment is behind my home router, I've already configured to allow VPN pass-through for UDP ports 500 and 4500 and port forward to the internet interface of my router virtual machine, which in my case is routing and remote access virtual machine router 01, and the IP address of its internet interface is 192.168.1.112. Here is the overall deployment workflow. I'll create a gateway subnet in my VNet1 to deploy a virtual network gateway resource in that subnet. Next, I'm going to deploy a virtual network gateway into the gateway subnet. I will then create a local gateway. So a local gateway represents the on-premises VPN device. After creating the local network gateway, I'm going to configure the on-premises VPN device, which in my case, it is routing and remote access server, router 01. In here, I'm going to create a demand dial interface to connect to Azure's virtual network gateway. Once we have everything in place, I will create a site-to-site VPN connection in Azure between Azure Virtual Network and the local virtual network that represents the on-premises VPN device. Finally, I will test and verify the VPN connectivity. Okay, the first step is to create a gateway subnet in my virtual network VNet1. And this gateway subnet is going to host the virtual network gateway. So I've logged into Azure portal, search and open virtual networks. In the virtual networks window, I'm going to open up VNet1, and this is where I'm going to create the gateway subnet. I'll click on subnets and click on gateway subnet. Now in the add subnet blade, I'm going to specify the subnet address range for the gateway subnet. I'll specify 10.0.1.0/29. And a /29 or a 28 subnet is good enough since you don't need a big subnet such as /24. And notice you cannot change the name of the subnet, which is gateway subnet, because Azure uses this subnet automatically to deploy the virtual network gateway. Okay, no other changes or selections are required. Click on save. Now ensure that the subnet is successfully added and listed in the subnet section of the VNet. All right, now you can see the gateway subnet. After creating the gateway subnet, you can deploy a virtual network gateway for a VPN connectivity between Azure and on-premises network. Back in the Azure portal, I will type virtual network gateways and open it. In the virtual network gateway window, you can click on this create button or click on the create virtual network gateway button up here. All right, under basics tab, you're going to select your subscription. I will keep my pay-as-you-go subscription. And there is no need to specify the resource group because it is derived from the VNet's resource group. In my case, it is resource group 1. Now I'm going to name the virtual network gateway. I will name this as VPN GW1. Next, you need to specify the region. I will keep East US. Now you need to specify the VPN gateway type. You can either specify VPN or express route. I will specify VPN. Next, you are going to specify the VPN type. You can either specify route-based or policy-based. I will select route-based. And the type of VPN you need to choose depends on the make and model of your on-premises device and the kind of VPN connection you intend to create. I'm going to select route-based gateway, but you need to select route-based gateway if you want to use point-to-site, inter-virtual network or multiple site-to-site connections. But if you're creating a VPN type gateway to coexist with an express route gateway, you need to use IKE v2 protocol. And policy-based gateway supports only IKE v1 protocol. So I'm going to select this back to route-based. Next, you need to specify a SKU type for your virtual network gateway. Since this is a lab, I'm going to select basic. But if your current SKU is basic, standard, or high performance, it can be upgraded or downgraded to a basic, standard, or high performance SKU. And if the current SKU is a VPN gateway 1, gateway 2, gateway 3, it can be upgraded or downgraded to VPN gateway 1, gateway 2, or gateway 3. If the gateway is being created to coexist with an express route, you can choose any of these SKU except basic. Alright, so this is the entire list of SKU which are available for the VPN gateway. Next, specify the generation of the virtual network gateway. I'll keep the default selected, which is Gen 1. And also basic and VPN gateway 1 are supported on Gen 1 only. But if you select, let's say, VPN gateway 2, you get the option to select either Gen 2 or Gen 1. So other than basic and VPN gateway 1 SKU, all other SKUs support Gen 1 as well as Gen 2. I'll select this back to basic and it is a Gen 1. All right, now we are going to specify the virtual network. I'll select VNet 1. Since this gateway subnet 10.0.1.0/29 is already created, it will select the gateway subnet automatically. Since the on-premises VPN device needs to be able to communicate with this virtual network gateway over the internet, this gateway needs to have a public IP address. And you can specify if you would like to create a new public IP address or use an existing one. I will select create new. I'm going to specify a name for the public IP address, VPN gateway 1, PIP1. Next, you need to specify the public IP address SKU. Since the public IP address is going to match the SKU of the virtual network gateway, by default it has selected to basic and it cannot be modified. Assignment, since the public IP address SKU is basic, I cannot select this to static. So the default assignment is dynamic. You can enable the active mode by selecting the option enabled, but for this demo, I'll keep it disabled. But if you want to use your VPN gateway for active mode, you need to select one of the high performance SKU. Next, you can enable BGP routing by selecting the option enabled and specifying the ASN number and things like that. But for this demo, I'll keep it disabled. And BGP routing can only be configured with route-based VPN gateway with the supported SKU type VPN gateway 1, gateway 2, and gateway 3. I'm going to click on next tags. And if you want to specify any key value pair for this resource, you can do that by specifying the tags. I'm going to click on next review plus create. It's going to run some validation and ensure that the validation has passed. And you can review your selection. And I'm going to click on create. Now it will take around 45 minutes to an hour for the deployment to complete. I'm going to speed up this video. Okay, it is done. Ensure that the deployment is successful. Back in the virtual network gateways window, ensure that your VPN gateway is listed here. I'm going to click on my VPN gateway. And we can see its public IP address, which is 20.231.126.187. And this public IP address will be used to configure the on-premises VPN device because the on-premises VPN device needs to know what the public IP address is of the Azure Virtual Network Gateway so it can communicate with it. After deploying the virtual network gateway, the next step is to create the local network gateway, which represents the on-premises VPN device. Back in the Azure portal, I will search and open local network gateways. In local network gateways window, you can click on create up here or create local network gateway button. And in the create local network gateway window, under basics tab, specify your subscription. I will keep my subscription, pay-as-you-go subscription, and I'm going to select my resource group 1. Next, specify a region. I will keep East US. Now I'm going to specify a name for my local network gateway. I'll name this as on-premises local GW1. Specify the type of endpoint. You can either select IP address or FQDN. I will keep IP address. Now you need to specify the public IP address assigned to your home router. Now in my case, the public IP address is a dynamic IP address and it may get changed if I reboot my router, which would be same for the routers of any home users. Also, the public IP address would not be assigned directly to your home router in most cases. It would be assigned with a private IP address. But if you would like to know what is the public IP address to your home router, you can use any online services such as what is my IP. So I'm going to open a new tab and type what is my IP, and you can see my public IP is 223.231.133.216. So I'm going to copy this and I'm going to paste it here. Also, if this public IP address gets changed, then you need to change the IP address in your local network gateway. Now under address space, you need to specify one or more IP address range in CIDR format that defines your on-premises network's address space, which are typically behind your on-premises VPN device. In my case, it is 192.168.10.0/24, which is the subnet of my internal network in my on-premises network. If you have multiple IP address space in your on-premises network, then you can add them as additional address range. By defining the address space of your internal network and the public IP address of your on-premises VPN device, you are telling Azure's virtual network gateway that the on-premises VPN device can be reached at this public address right here. And the internal networks that are defined under address space or the underlying network address range of our on-premises network that we can access through VPN. But if you plan to use this local network gateway in a BGP enabled connection, then the minimum prefix you need to declare is the host address of your BGP peer address on your VPN device. In my case, I'm not using BGP peer IP address, so I'm going to click on Next, Advanced. Under the Advanced tab, you can configure the BGP settings by selecting Yes and specifying the ASN number as well as the BGP peer IP address. Since I'm not using BGP routing for this demo, I will keep it selected as No, and I'm going to click Next, Review plus Create. Ensure that the validation has passed and you can review your selection and click on Create. Ensure that the deployment is successful. Back in the local network gateways window, ensure that the newly created local network gateway on-premises local GW1 is listed. The next step is to configure the on-premises VPN device, which in my case is the Windows server running routing and remote access role. I've already logged into my routing and remote access server. So I'm going to open up Server Manager, go into Tools and click on Routing and Remote Access. I'm going to right click on Router 01. And the first step is to configure and enable routing and remote access. And I'm going to click on Next and select Custom Configuration. Click Next. I'm going to select VPN access as well as LAN routing, and click next and hit finish. Click start service. All right, the next step is to create a new demand dial interface. So right click on network interfaces and select new demand dial interface. Click next. Specify a name for the interface. I will type Azure S2S and click on next. In the connection type, I will keep the default selected, which is connect using virtual private networking, VPN. Click next. In the VPN type screen, select the type of VPN connection. I'm going to select IKE v2 and click on next. In the destination address screen, specify the public IP of the virtual network gateway. So if I go back to virtual network gateways and click on my VPN gateway, you can see this is the public IP address of this virtual network gateway. I'm going to copy this and come back to my routing and remote access server and paste it here. Click next. In the protocol and security, keep the default selected, which is route IP packets on this interface. Click next. In the static routes for remote networks, you need to add a static route of our subnet that contains our Azure virtual machine, VM1. So I'm going to click on add. In my case, it is 10.0.0.0/24, which is 255.255.255.0. Specify a lower metric which provides you the higher priority. I'm going to specify 10 and click on OK. Click next. In the dialogue credentials screen, you don't need to specify any credentials, so you can skip this. Click next and click finish. Now right click on this new demand dial interface and click on properties. Now we are going to update the connection type and the password for the new demand dial interface. Click Options tab and make the connection type as persistent by selecting Persistent Connection. Click Security and under Authentication, select Use Pre-shared key for authentication. Specify a pre-shared key. I'm going to specify a standard one. And by the way, this is the same password which you need to update in your site-to-site VPN connection in Azure. So I'm going to click on OK. Once we have the virtual network gateway configured, which represents the Azure endpoint, and the local network gateway configured, which represents the on-premises VPN endpoint, the next step is to configure the VPN connection between these two endpoints. So I'm back in Azure portal. I'm going to search and open connections. Click on Create. In the Create Connections window, under Basics tab, I'm going to specify my subscription, which is pay as you go, and I'll select my resource group 1. And for the connection type, you have a few different options: VNet to VNet, site to site, IPsec, express route. So in our case, it is site to site IPsec. And for the name, I'll name this as Azure to on-prem site to site. And I'll keep the default region selected, which is East US. Click Next, Settings. Under Settings tab, you need to specify the virtual network gateway in Azure that will be used to establish a site-to-site VPN connection with the on-premises VPN device. In my case, it is VPN gateway. Next, you need to specify the local network gateway, which is the on-premises device that will be used to establish a site-to-site VPN connection with the virtual network gateway. In my case, it is on-premises local GW1. Now you need to specify the pre-shared key that will be used for authentication and encryption of the VPN connection. And this is the same pre-shared key which must be used in both virtual network gateway as well as in the local network gateway. I'll specify my standard password, and this is the same password which I've used it in my demand dial interface. Next, you need to specify the IKE protocol. You can either use IKE version 1 or IKE version 2. Since this is a route-based virtual network gateway, I will specify IKE version 2 protocol. And moreover, IKE version 1 protocol is not supported on route-based virtual network gateway. Use Azure private IP address. Now, if you check this option, it allows you to use Azure private IPs to establish an IPsec VPN connection. Support for private IPs must be set on the VPN gateway for this option to work, and it is only supported on AZ SKUs. So I will keep this option unchecked. Since I'm not using BGP routing, I will keep this option unchecked. If the default option default is selected instead of custom, then IPsec or IKE policy will be negotiated while dialing the connection. So I'll keep the default selected. Use policy-based traffic selector. If you set this to enable, then the Azure Virtual Network Gateway will connect to a policy-based VPN firewall in your on-premises. So you need to ensure your VPN device has the matching traffic selector defined with all combination of your on-premises network prefixes to and from the Azure Virtual Network prefixes instead of any to any. I will keep this option set to disable, which is the default selection. Specify the dead peer detection DPD timeout of the connection in seconds. I will keep the default, which is 45. For the connection mode, I will keep this selected to default, and this will decide which gateway can initiate the connection. When this value is set to default, both Azure and on-premises VPN gateway can initiate the connection. But if it is set to responder only, Azure VPN gateway will never initiate the connection. Only the on-premises VPN gateway must initiate the connection. And if it is initiator only, then Azure VPN gateway will initiate the connection and reject any connection attempts from the on-premises VPN gateway. I will keep the default selected, which is default, and click on Next Tags. In here, you can specify the key value pair for your resource. I'm going to click on Next Review plus Create. Ensure that the validation has passed and review your selection and click on Create. Ensure that the deployment is successful. You can also create this connection by going into Virtual Network Gateway and click on Connections under Settings and click on Add. You can do that from the local network gateway as well. So open it and click on Connections and click on Add. All right, back to Connections. Ensure that the new connection is listed in the Connections window. Okay, now that we have created a site-to-site connection, it is time to verify the VPN connectivity. First, in my routing and remote access server, in the routing and remote access MMC snap-in, I will right-click on Azure S2S, which is our demand dial interface, and click on Connect. If you're not able to connect, you can try to ping the IP address of your Azure VM from your internal network, or you can ping the IP address of your devices in your internal network from Azure VM. I'll try it again and click on Connect. Okay, so it shows the connection state as connected. Now let me verify this in Azure Portal. It says the status as not connected. Hit refresh. Okay, you can see the status is showing as connected. And let me go back to home. Going to local network gateways. Click on it and click on connections. It is showing as connected here. And if I go into virtual network gateway and go into connections, and it shows as connected here as well. Let's see if I can ping any of the VM which is in my internal network. So I'm on my Azure VM and I'm going to ping the domain controller which is in my internal network. Okay, you can see it is already pinging. Let's see if I can ping my member server, server 01, and that is pinging as well. Let me go to my domain controller, open up command prompt. You can see the host name and you can see the IP address belongs to my internal network. So I'm going to ping the IP address of the Azure VM, which is 10.0.0.4. Okay, it is not pinging because I still have the firewall enabled. So let me turn off the firewall. I'll turn off all the profiles. If I go back and ping again, okay, so this shows that the VPN connectivity is fine. And this concludes the demo of creating an Azure site-to-site VPN connection. I hope you like this video. For more videos like these, please subscribe to my channel.